Hi folks, this is Don. I want to walk you through a chi-square goodness of fit problem to update a video that I did quite a while back. And we're going to do this problem using StatCrunch. And here the problem is, it gives us a distribution nationally for these various causes of fatal accidents. Transportation, there's 6 different categories there for the cause, and here's the breakdown on the national basis, the frequencies. And we went out and made observations in the western region and got these counts or frequency for each of those 6 types of causes. And we want to know at alpha 0.1, is the distribution of these causes of fatal work injuries in the western region different from that in the national? And that tells you this is a goodness of fit. We have to state the null. The null is always that the distribution is the same in the West as it is in the rest of the country. And so we would write out these percentages that 43% transportation, 18%, and so on. That would be the null. The alternative is that the distribution in the West differs from the expected distribution, and in this case, the claim is the alternative. We need to get the critical value, and we'll do that. I'm going to go ahead and load this data into StatCrunch. And now I'll go to Stat, Calculators, chi-square. Our degrees of freedom is k minus 1. We've got 6 categories, so that'd be 5. We always want the right tail, and the probability over there is 0.1. So that gives me a critical value for the chi-square test of 9.26236. And I think that's the answer, yes, that they have. Okay, I'm going to close that. Now we've got our data here, the causes, 6 categories, the national distribution, and the actual observed frequencies. We just go to Stat, Goodness of Fit, chi-square test, and our observed column, we drag this down, is Western. Our expected column is the national percent. I'm going to go ahead and display that and click on Compute. And there we have our answer. Our chi-square test statistic is 45.356. Our p-value is less than 0.001, very, very small. So it's obviously less than 0.1. So that would tell us to reject the null. We've got our observed and expected in case the question asks you for the expected. And because this chi-square statistic is much greater than our critical value of 9.236, we say we reject the null, and at the 10% significance level, there is enough evidence to conclude the Western is different than the national distribution. So I hope this helps.